I've worked with computers for about 50 years. My first computer of sorts was a Wang 500 calculator. You guys have one of those in your collection here? It's about yay big, about like that, yay high. Not a really portable calculator. So I've written a book about chips and my art, and I have them over there. And I've assisted museums with their chip collections. So this I can talk about. The Smithsonian, about 20 years ago, reached out to me because they were starting their own chip collection, and they didn't know what to collect. And the thing was, it's not like coin collecting where you can go buy coin collecting books and it tells you what to collect. Well, there was no such thing. There were a lot of engineering books that told you all the specs and everything. So it really was amongst those who actually had been in the time that would start sharing information with those of us who were trying to collect this stuff that we started piecing the story together. It was almost like a lost history that we started putting back together. We count in what we call base 10. And we count 1, 2, 3, 4, 5, 6, 7, 8, 9, and what comes next? 10, exactly. So interesting is we have these 10 symbols, but here we actually start using the symbols over again. And so we go 11, 12, 13, 14, and 16. We're going to stop here for a reason. I'm a math major, so this kind of stuff I really get into. It turns out that base 10 is not the only way to count. There's different systems. And computers, we found it was much cheaper to use what we call base 2 or binary. It's the ones and zeros, the ons and offs, the trues and false. That's what you can do with a computer. But when you count this way, you go 0, 1, and then you go 1, 0. It's like 10? No, it's not 10. It's actually 2 because the positions in base 2 are the 1's place, the 2's place, the 4's place, the 8's place, 16's, and so on, rather than the 10's, 100's, 1000's. Okay? So when you start counting, every time you get to the 1, that's like hitting the 9, and we're going ahead. And so we keep going through, and we start getting very big numbers. It seems like it's overly cumbersome, but it's very easy for computers to deal with all these little bits. So now that you know this, you're in on this tech joke. There are 1, 0 types of people, those that know binary and those that don't. All right, so how does a computer say yes, no, true, false, 1, 0? Well, the first computer that was built with relays was built in 1941. Now, the way this works is that this is an electromagnet. When it is powered on, it pulls this piece of metal down, and when it's off, this little thing here can connect with the top, but when the magnet goes on, it pulls it down and it connects with this one. So there's your 1 and 0. And the interesting thing is this scheme of how you create logic is carried on in everything since, because this is what's considered a control, and this is considered the information. So you have something that controls the circuit, and the other one that actually passes the 1 or the 0. Now, to go to the next generation, we have to go back in time to the Edison effect in 1880. Not only did Edison invent the light bulb, but he invented the first, I forgot the exact name of it, but it wound up being a diode. A diode allows electricity to pass in only one direction. So in the way this worked was he realized that when the filament was heated, electricity would actually be freed, and it, depending on how the glass was charged, you could get black spots on the glass. and he realized, oh, something's happening. Something's going through the vacuum. And we didn't know about electrons back then. So he added another electrode to this, and he realized that electricity would only pass in one direction. And he called that a diode. He patented this, and then he stopped. So the next turn of the crank for us was the vacuum tube. And the reason why vacuum tubes are so hot is because they work just like this original light bulb, is they heat up an element, it spits off electrons, and goes to another electrode. But in here, they put a grid in the middle, which either allows electricity to pass or to stop. And so the first computer built with this was back in 1946. And then we went to transistors. Much smaller, very cool, very reliable, but it was only a single transistor. And the first computer built with those was in 1954. So this is a transistor. And this looks complicated, but it actually really, so you have these three connectors, the emitter, the base, the collector. So the emitter is where the electricity comes in. There's different types of what they call doped silicon. And what would happen is if there was current applied to this middle section, it would either block or pass electricity going from the emitter to the collector. So, and this is an actual picture of one. And it goes like this and over, and then this is the part that actually blocks it. So we essentially built the same equivalent as the relay or the vacuum tube in the same form. Now this is where the real magic happened. So there was a guy by the name of Gene Herney who worked for Fairchild. And he got this idea that says, you know, that bulky transistor is great, but let's see if we can't figure out a better way to manufacture transistors. And what he realized was he could use the printing technology, lithography, where they would etch plates, where you would put the letters and pictures and stuff like that, and books and stuff like that. But he used it to, instead of building that bar, he actually built layers of, he would have a layer of N silicon, P silicon, which are negative and positive, and then yet another P layer, and depending on whether he was doing NPN or PNP. But the bottom line was he was able to build the same thing, but it was nice and flat. And what that allowed was the next major turn of the crank was the integrated circuit, or at least the silicon integrated circuit. The real first integrated circuit was actually a vacuum tube long, long ago. So this is a Fairchild 915. These were actually used in the Apollo guidance computer. There's one in the other room. And these areas where you see three connectors coming to them are transistors. So they figured out, and this was Robert Noyce, who went on to found Intel. These are each of the transistors on this. And so you were able to build what they called a dual 3-input NOR gate. Texas Instruments was hot on their heels. They created actually the first commercially available integrated circuit. And I'm going to show you a little bit more about how that was built. So this is that same circuit we were just looking at. This is the, you know, an electrical engineer would say, oh, this is wonderful. I can tell what this thing does. You know, I couldn't really. So this is a capacitor. This is a resistor. This is a transistor here, the logical symbol for them. But this indicates what this circuit does. But I can show you what the different parts are. So a diode, which allows electricity to flow in one direction, is this little thing here. It's not this bar here. That actually is going over the top of it, but this is the diode itself. This right here is a resistor, and the length of the resistor depends on which restricts the flow of electricity. And then this over here is a capacitor, which stores charge or electricity. And then these are the transistors right here. And over here and here. Okay, so you got this all? So if you got this, you're EEs now. So how do you make a chip? You start with sand. If you ever go to Panama Beach in Florida and you see that nice white sand, that's what they like to use to make chips. It's silica sand. The interesting thing is, everybody says, oh, the sand on beaches, that's made from all those little shells and everything that are all ground up. It's not true. It's actually mostly from granite that comes down from the rivers that accumulates on the beaches. And so this has a lot of silicon in it. We heat it up to like 2,500 degrees Fahrenheit. The whole process of making chips is like hell. It's just really hot, melting and combining of stuff. So we get silicon carbide is really one of the first major byproducts of melting that sand down. We then get to silicon, which we have over there. We got some nice big chunks of it. And this stuff is pure. It is like if you're into crystals and health and all this stuff, these are the purest crystals on the planet. And what they would do is they would have this a furnace where they would have a crucible in here that would be at like 3,200 degrees. They would throw chunks of those polysilicon into here. They would take what they call a crystal, this little pole here, and dip it in here, and then they would start pulling it out. And you notice that this is narrower at the top. Well, they would pull it, and depending on the speed, would determine the thickness of this. Now, this was from 1971, so this would have been about a 3-inch, what they call a boule. I call it a salami. And this is a 6-inch, 26-pound one, and I actually brought it, have it over there. But the very first ones were very small, barely an inch. And this is what they made the first chips on. So when they would make what we call a wafer, we would take that salami and we would slice it. Now I just took a vacuum tube on here just to use as a prop, because the first thing that we do after we cut them is we polish them. When we polish them, they get incredibly flat. Now, at the same time, it actually turns it into a mirror. That's not why we do it. It's because we want it really, really flat to start building the chip on it. So we go through a process called etching, which we're going to talk about in a minute. And each of these little rectangles is a completed chip on it. These black ones are called test chips, and they're used to verify that the manufacturing lines are working properly. So this is what an individual chip looks like on that wafer. Now, we're going to look at just this one little area here and how we actually build that up. So this is what it looks like when it's complete. And so now we're going back to when it's completely flat. Not very interesting. But this is what it looks like after we've put a couple of layers on here. And so we add a couple more layers, and it starts building up as we're building up this circuit. And then this is what the completed chip looks like. All the different parts are there. So this is about 7 layers deep. For something that's flat, it's very complicated. It's very much of a 3D structure. Today's modern chips, well over 32 layers. And the biggest problem is not having the chip overheat. So that's one of the challenges that they have to deal with. So we have to test the chips. But why would a chip fail? Because it gets nervous? No. It's because of contamination. So this is a memory chip. Each one of these rectangles here are actually 4 bits. And this is one of my hairs, and this is my dandruff. But it shows how much if you're in building these chips and it's not clean in there, what the damage that it can be caused. And so Intel many years ago came out with this ad where they showed people in the bunny suits, these clean room suits, dancing around holding their products, and it was really cool. Okay, so we get the completed wafer. It's tested. Now, that tester, as it goes around, it powers up every single one of these chips while it's still here. Not after it's been cut, but right here on here, they turn them on and they run them and see if they work. And if they don't work, then a little black pen comes down and marks each of those chips with a dot on them. So this is so that later they can be separated. So this is a wafer that has been what we call diced. This is a really thin diamond saw, and it goes and it cuts this thing into rows and columns as we go through there. And I brought one just so you can see this. Normally, when you have a chip, it's nice and solid. It goes tunk, 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 tunk when you're doing it. But I don't know if you can see this, but you can see my fingers. Okay, and that's because each one of these, I could sit here and peel each one of these chips off if I wanted to. So I'll let you guys play with this if you want. So it's diced. We pull off the good ones. We throw away the bad ones. And this is what they look like after they've been cut. These particular chips actually had gold put on the back side of them to improve conductivity. But as you can see, they're very small. So this is what, we take that chip and we put it inside what's called a package. And this is the chip itself right here. And you may have noticed that there are little pads around the sides, and that's the connecting points for the circuits. And they tie wires that will go from here all through this package all the way over to this lead here. And so this is how this chip talks to the real world. Now this particular one is unique in that it could store memory and then it could be erased. So it has a quartz window on top of it. This actually was the very first chip that could remember data when power was removed. It was stuck on a board, but essentially it was the very first thumb drive. Now, chips are put into all kinds of different packages depending on the engineering requirement, but there's lots of different kinds. Okay, so how did ChipScapes come to be? When I was in college, I was taking a class on microprocessors and logic chips and things like that. And the Intel 8080 microprocessor that we were using went bad. And my professor pulled it out and he says, "Do you want this?" Little did he know what he was starting. So this was back in 1978. And I started going to electronic surplus shops. I started going out and getting on Usenet. I mean, there really wasn't an internet to really, the www was not here yet. And I would go to Hamfest, any place where they might have chips, I would go. So my collection grew. And then in 1995, some magic happened. And there was this one site that very specifically was the magic. And for anybody who collects anything, they know about eBay. And so my collection grew to about 40,000 chips. So now I've been selling some of it, and I've been donating some of it, and so now it's much more manageable. It's only about 20,000. So why did I start doing this? Well, people would ask me that, and I'd say, well, it's like the equivalent of high-tech bottle cap collecting. And what's a computer chip? Well, they make computers go. That's, And then they would hit me with the hard one is, why would you bother? They all look the same. And it's not really true. But, without going into a lot of detail that would bore them to death, I really couldn't figure out a way to really kind of express my passion about computer chips. And so I bought a microscope and started taking the pictures of the insides of the chips. And that's when I really started realizing there's a whole lot of difference between this package and the actual real chip that's down inside it. So this is actually one of the very first photographs I took of a chip. This is a transistor, and this used to have a metal cap over the top of it, and I pulled it off. This is the chip itself. This is a transistor, and you can't quite see it, but there's little wires that go from here over to here, and these are the connectors, the emitter, base, and collector. And it was interesting, but it wasn't enough, so I had to get a microscope. So then I was able to jump in and say, okay, yeah, here's this same chip, but much bigger, so I can actually see the detail of it. And you could see the wires going over to the leads. And that was cooler, but I would show that to people, and it was like, okay, cool. So I realized I had to come up with a secret sauce, and this is where I started playing with light and combining images. And this is my very first ChipScape from 20 years ago. Now, it looks cool, but technically it was very difficult to actually get this whole wire in focus. So I had to use this, taking multiple images and combining them. And then to get these colors to come out, really you had to use different colors of light from different angles to make that happen. And I was really into computer technology. I really wanted to know how things were made, why they were made. That actually bothered me more in a lot of cases than the how. And then who made it happen? What was their motivation? Why did they want to do this? And photography, that's something I had done from a fairly young time. And I love working with my hands. So every part of a ChipScape, everything I do it. So it's the framing, everything. Okay. So this is generally what a chip will look like if you look at it under the microscope. It's very gray. But through the magic of ChipScapes, I can take something like that and make it look like this. In any kind of art that you do, and if you want to kind of be good at it, you have to take different approaches. So you need to find something that's interesting about your subject, whether it be chips or bottle caps or whatever. But find something that's either visually interesting or something about the technology and it's got a good story. Play with the light, the colors, the angles, multiple images, and tools. Depending on what you're doing, you might try and find different kinds of ways of taking pictures or painting things that are just in a different way. And in my case, I used a lot of image manipulation tools. Experiment with different views, try and look at it in a way that nobody else would. Different combinations, embrace your mistakes. Of course, there's no mistakes, there's only happy accidents if you're a Bob Ross fan. And I firmly believe that because there are so many things that I screwed up. Oh, wait a minute, that's kind of cool. Okay, so we're going to make a ChipScape. So here's a picture I took of that actual same chip that we saw that we were just working on. And it's like, okay, well that's okay, but let's see if it might look better this way. Yeah, okay, but the composition's not so good. Let's clip off a little bit. And then let's try and put some different colors on it and see what happens. And okay, that's interesting. But let's see if we can, if we combine the images, if things start looking more interesting. And then we play around with different combinations, and so we tweak the sauce. And it's starting to look pretty good. More interesting until there. I'm finally happy with it, okay? So that's the kind of thing I do, is when I look at chips, I try all kinds of different techniques to see if I can bring out what's interesting about that chip. But the idea is it's done in a shadow box frame. I build it in panel form. I have the various artifacts, transistors, chips, boards, whatever I want to put in there. And I build them up, and I kind of make it sort of look like a chip as I'm doing this. So I do that, and then I also put a backstory on the backside so that if anybody ever buys one of my artworks, if you have that know-it-all who comes up and starts telling you everything about your artwork, there's always stuff on the back that they're not going to know. So you can be the expert. It's also, I could never find a way to get all the information on the front. So this is an Intel 4004. It's the world's first microprocessor, and it's one of my favorites. And it seems to be like a crowd favorite too. A lot of people like this one. But for fun, I went through on this one and I just blocked off what the actual circuits. There's 2,300 transistors in this thing. And these are what the different sections do in the microprocessor. So what do chip designers do for fun? Well, have you ever heard of a hidden Mickey? Okay.
Mickey right there.
That's right. Well, so if you ever go to any of the Disney stuff, they have hidden Mickeys in the carpets, in the wallpaper. They do this on purpose, and it's one of the fun things to do at Disney. How about Easter eggs? So you find these all the time. They're hidden, and that's really cool. Well, chip designers do this, but the thing is, they never have any hope that anybody's ever going to see it, because it's buried inside that package. But they do it anyway. So I'm going to show you one. So essentially. So what is chip art? It's stuff that designers put on the chip that don't do anything except amuse the designers. So, all right, so here's a chip. It's got a dot on it. What does that mean? Doesn't work. That's right. So now in the dead center of that is actually a piece of chip art. If I keep zooming in on it. So it's actually, this is a General Motors chip that was used in their cars, and that's the Delco Electronics logo. And you can see it is hidden underneath these traces, which is where the electricity goes. Personally, if I were the manager, I would not have allowed them to put it there. Usually they put it in space where there's nothing going on, but these are like right underneath where the electrical lines go. You could have inductance problems. And
right below it, that kind of looks like the GM logo.
it is. Yeah, absolutely. So what kind of things do they put on chips? Well, all kinds of stuff. So for the General Electric, there's one with that. There's the one that I have that has tons of stuff on it, and particularly they have the StarTech Enterprise, and it's the only one I've ever found that actually has the phasers going. Alfred Hitchcock from Alfred Hitchcock Presents 1960s show. The Aloha one is one of my favorite stories. I actually didn't know it originally, but when I posted it, a guy responded and he told me about the story of this, which actually happens a lot, by the way. I get contacted by a lot of the original chip designers and stuff like that, and they tell me all the original stories of what they did when they went to create these chips. This was one where they were given an incredible deadline that they had to meet, and they were told that if they met the deadline of making this chip, they would get a trip to Hawaii, and they did. And so they put Aloha on the chip. This one is a memory chip. It's a RAM with lightning bolts coming from its nose. This is from the Sandia National Labs. There's their Thunderbird logo. So this one was actually taken from Risky Business, the movie. The Dream is Always the Same. MC Hammer, this is a Can Touch. This was a security chip that was used that was designed to go in a ring where you touched it to create the security. And then this one was one where these guys created 3 different chips for their management team, and they did it for Christmas, so they put presents under the tree. And then this one down here is my favorite. It's really kind of hard to see, but This was put on a Digital Equipment Corporation VAX chip, if you're familiar with that from way back when. But this was during the Cold War, and at the time, Hallmark used to have this slogan. It said, when you care to buy the very best, you get a Hallmark greeting card. Well, they wrote in Russian on the chip, because Russia was copying our chips, and they wrote, VAX, when you care to steal the very best. So where can you see more ChipScapes? Well, we have one of the largest collections in the world right here. I have a bunch that are up at Swansea University in the UK. I have some at the PC and Communication Museums in Bern, Switzerland. And there's stuff in the gift shop. Yeah. Now, the one show that I actually do is the Maker Faire in Orlando. It's one of the, if you've never been to a Maker Faire, you should go. They are really awesome. But ours in Orlando is the 9th and 10th of this year. I will be there. I have my book. You can take a look at it over there. If you want to buy one, you can get that over there. I'll be happy to autograph it. And my website, which is chipscapes.com.